Okay, we'll see the problem number 2.6 part B, in which they give this is minus Vx. Here they give voltage divider network R2 and R1. We need to find Ix, we need to find Gm with respect to Vx. Okay, so same way what we did in problem number 2.6a, we can do here. VDS is VDD minus Vx, difference between this. So this is VDD. VDD minus Vx will be VDS. VGS is VDD minus Vx into R2 upon R1 plus R2y, because drop across this resistance will be VGS of M1. This is gate, this is source, and this is drain. So in the previous video, in the A part, here was the VGS, because of that was PMOS. Okay, so but here you will need to see that, okay, the drop of R2 is VGS. Fine. So here, so same way for here, for this circuit we can find the minimum ratio for which the M1 will get some VTH more than some VGS more than VTH, such that some current can flow. If ratio is lesser than that, you will not able to get any current. If you will find that ratio, that is this one. If R2 upon R1 plus R2 is less than 0.7 by 3, you will not able to get current. So we are assuming that the ratio is higher than this. Basically the value of R2 should be somewhat higher, such that it can drop some voltage greater than VTH at some value of Vx, not for all. Okay, you can go for all also, but just to have a idea of what this problem is trying to tell us, we are not going for those kind of condition in which this MOSFET is always on. Okay, so first of all let me draw it, Vx and Ix. After some point, if you will go beyond the value of Vx, you will not get current, same as the previous problem, because this Vx will go up, this drop will go down, and ultimately this drop will go down. So the enough VGS will not be there, so I will be 0. And what is that point? You can find from this equation. Okay, this is 3 minus 0.7 R1 plus R2 by R2. This is the point. I am telling this A point. So beyond A point, I is 0. Same goes for, because I is 0, beyond the A point, Gm will also be 0. Okay. Okay. So what will happen here? The value less than that point A. What will happen? We'll see that what is VDS here? VDD minus Vx. And what is VGS minus VTS? That is VDD. This actually I should write the same way. VDD minus Vx R2 by R1 plus R2 minus 0.7. So again, if you will see, this will always be higher. So below this point, I mean the value of Vx, if below point A, that is always saturation condition for M1, at least for this this equation. So the equation, you know, I set and Gm set saturation. Okay, you can just find that equation and you can just put it. You will get some this kind of curve. This is straight line. Why? Because in the equation of I, this is proportional to VGS, that is VD minus Vx to minus 0.7 square, and Gm proportional to same ratio but don't same value, but square will not be there. Okay, so you will get this. You can find this point if you have R1 and R2 with value. Okay, so this is the solution of points 2.6 part B. We'll see part C after this.